In this video, I am going to solve 3 marks questions of section C Mathematics Basic Question Paper of QP code 436/6/1 set 1. Now let me solve question number 26, which are taken from the chapter Polynomials. Please watch the video till the end and don't forget to like, share and subscribe. 26a. If alpha and beta are the zeros of the quadratic polynomial 8x square minus 5x minus 1, then form a quadratic polynomial in x whose zeros are 2 by alpha and 2 by beta. Or you can also solve. Find the zeros of the polynomial p of x, that is equal to 3x square plus x minus 10, and verify the relationship between the zeros and the coefficients. Now let me solve the 26th A question. Here let p of x be 8x square minus 5x minus 1 and alpha and beta be the zeros. So the sum of the zeros is equal to negative of b by a, that is negative of 5 by 8, that is equal to 5 by 8. And the product of the zeros c by a, that is equal to negative of 1. Quadratic polynomial whose zeros are 2 by alpha and 2 by beta we have to form. So the required polynomial is q of x square minus 2 by alpha plus 2 by beta into x plus 2 by alpha into 2 by beta. So q of x is equal to, here you have to add these two. How will you add? LCM is alpha into beta. In the numerator 2 beta plus 2 alpha x plus, here you have to multiply both denominator and numerator. 2 into 2 4 by alpha into beta. So q of x is equal to x square, here 2 is common, 2 into alpha plus beta by alpha into beta into x by 4 by alpha into beta. Now let us substitute the values of alpha plus beta and alpha into beta. So q of x is equal to alpha plus beta is 5 by 8, alpha into beta is negative of 1 by 8. 4 by alpha into beta is negative of 1 by 8. That is equal to x square. Here what happens? 8 and 8 get cancels. Here negative value, so negative of 2 into 5, 10. So negative of 10x, here it goes to the numerator. Negative of 8 into 4, that is 32. So q of x is equal to x square plus 10x minus 32 is the required polynomial. Now let us solve the 26b. Find the zeros of the polynomial p of x is equal to 3x square plus x minus 10 and verify the relationship between the zeros and the coefficients. Now let p of x is equal to 3x square plus x minus 10. 0 of the polynomial is the value of x where p of x is equal to 0. So let p of x is equal to 0. 3x square plus x minus 10 is equal to 0. Now let us factorize. coefficient of x square into c, that is negative of 30. Now let us split 30 to get 1. 6 and 5 are such numbers. Positive of 6, negative of 5. Now let us group. Here 3x is common, here 5 is common. So x plus 2 into 3x plus minus 5 is equal to 0, or 3x minus 5 into x plus 2 is equal to 0. 3x is equal to negative 3x is equal to 5, so x is equal to 5 by 3. X is equal to negative of 2. So zeros of the polynomial are alpha is equal to 5 by 3 and beta is equal to negative of 2. Now let us verify the relationship between the zeros and the coefficients. We know that sum of the zeros alpha plus beta is equal to negative of b by a. Alpha plus beta 5 by 3 minus 2 plus into minus 2. Here LCM is 3, that is equal to negative of 1 by 3. Negative of b by a. Here b is 1, so negative of 1 by 3. So this is equal to this. So hence sum of zeros alpha plus beta is equal to b by a is verified. Now let us verify the relationship between the product of the zeros alpha into beta, which is equal to c by a. Alpha into beta is equal to 5 by 3 into negative of 2. That is equal to negative of 10 by 3. C by A. C is negative of 10. A is 3. So this is equal to this. LHS is equal to RHS. Hence the product of zeros alpha into beta, that is equal to C by A, is verified. Now let us solve the 27th question of section D, which carries 3 marks. Find the length and breadth of a rectangular park whose perimeter is 100 meter and area is 600 meter square. Now let this be the rectangular park. Let the length of the field be x meter and breadth be y meter. Perimeter 2 into L plus B means 2 into x plus y, that is equal to 100 meter. So x plus y is equal to 50. 100 divided by 2. So y is equal to 50 minus x. Area of the rectangle is equal to length into breadth. So 600 meter square is equal to x into y meter square. X into, substitute the value of y is equal to 50 minus x. So x in 600 is equal to x into 50 minus x. Now multiply 50x minus x square is equal to 100. Writing in the standard form, x square minus 50x plus 600 is equal to 0. Now let us factorize. Minus 30 minus 20 is equal to minus 50. If you multiply minus 30 and minus 20, you will get 600. Now group x square minus 30x minus 20x plus 600. X into x plus 30, x minus 30 into, here 20 is common, x into x minus 30. 20 into x minus 30 is equal to 0. X minus 30 into x minus 20 group. like this. So x is equal to 30 or x is equal to 20. So the length of the rectangle x is equal to 30. Now let us take the bigger value. Breadth y is equal to 50 minus x, that is 50 minus 30, that is equal to 20 meter. Now let us solve 28th question of section C, which carries 3 marks. The question is, 3 measuring rods are of length 120 cm, 100 cm and 150 cm. Find the least length of a fence that can be measured an exact number of times using any of the rods. How many times each rod will be used to measure the length of the fence? We need to find LCM of 3 rods of length 120 cm, 100 cm and 150 cm. The LCM represents the shortest length that can be measured exactly using any of the 3 rods. Now, using prime factorization method, let us find the LCM of 120, 100 and 150. 120, let us prime factorize it. So 120 is equal to 1 into 2 cube into 3 into 5. Now let us prime factorize 100. So 100 is equal to 1 into 2 square into 5 square. Now let us prime factorize 150. So 150 is equal to 1 into 2 into 3 into 5 square. So LCM is 2 cube. Highest number is 2 cube, 3, 5 square. Okay, now 2 cube into 3 into 5 square is equal to 600. Number of each time each rod is used. 120 centimeter rod, 600 by 120, 12 5s are 60, so 5 times. 100 centimeter rod, 600 into 100, which is equal to 6 times. 150 centimeter rod, 600 divided by 150, which is equal to 4 times. Now let us solve 29th question of section C, which carries 3 marks. The question is taken from the chapter Areas Related to Circles. AB and CD are diameters of a circle with center O and radius 7 cm. If angle BOD is 30 degree, this one is 30 degree, then find the area and perimeter of the shaded region. Here it is very important to note that angle COC is also 30 degree because they are vertically opposite angles. What has been given? Radius is given 7 centimeter. Angle BOD, central angle, that is 30 degree. To find area and perimeters of the shaded region means we have to find the area of 2 sectors, sector BOD and sector AOC. Their areas are similar since they share same radius and also same central angle. And also we have to find the perimeter, means we can find any perimeter of any one sector and multiplied it with 2. Now area of the shaded region, let us find out. Area of sector ODB plus area of sector OAC. Area of sector formula is theta by 360 pi r square. Here theta is equal to 30 degree. So angle COD is also 30 degree because they are vertically opposite angles. Area of the shaded region is equal to 2 into area of any one of the sector, that is theta by 360 into pi r square. Now let us substitute the values. 2 into 30 by 360, theta is 30. 22 by 7 into 7 into 7. Here we can cancel 7 and 7, 0 and 0. 3 ones are 3 12s are 2 ones are 2 6 are 2 3s are 2 11s are. So now we have 77 by 3, which is equal to 25.66 centimeter square. So area of the shaded region is 25.66 centimeter square. Now let us calculate the perimeter of the shaded region. Perimeter of the shaded region is equal to perimeter of the sector ODB plus perimeter of the sector OAC. Perimeters of these two sectors are equal since they share the same radii and also length of the arc. Okay. And theta is same here. Perimeter of the sector formula is 2r plus theta by 360 into 2 pi r. 2r because this plus this length of the arc is equal to theta by 360 into 2 pi r. Now let us substitute. So perimeter of the shaded region is equal to 2 into, because there are two such regions. 2 into 2r plus theta by 360 into 2 pi r. Now let us substitute the values. Here we can cancel 0 and 0. 3 ones are 3 12s are 2 ones are 2 6 are 2 3s are 2 11s are 7 and 7 get cancels. So in this region now we have 11 by 3. Here we have 14. So this is equal to 14 plus 11 by 3. 11 by 3 is equal to 3.66 plus this 14, that is equal to, okay, let me solve. 77.66 into 2. What is it? 2 6 are 12, 2 6 are 12, 1 13, 2 7s are 14, carry 1, 2 ones are 2, 1 3, approximately equal to, because I haven't expanded here, only this much I have done, 6 I have stopped. 35.33 centimeter is the perimeter of the shaded region. Now let us solve the question number 30, which is taken from the chapter trigonometry. Tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta is equal to secant theta cosecant theta plus 1. Now LHS is tan theta upon cot theta plus cot theta upon 1 minus tan theta. Now let us convert tan theta into sin theta over cos theta. So upon 1 minus cot theta into, let us convert it as cos theta upon sin theta, plus cot theta into cos theta upon sin theta upon, here let us convert tan theta into sin theta over cos theta, that is equal to sin theta upon cos theta. Here LCM is sin theta. So sin theta minus cos theta upon sin theta, this plus sin cos theta upon sin theta upon, here LCM is cos theta, so cos theta minus sin theta upon cos theta. So this is equal to sin theta upon cos theta. Here write the reciprocal value of this one, sin theta upon sin theta minus cos theta plus cos theta upon sin theta. Here also this goes to the numerator by cos theta minus sin theta. Here sin theta into sin theta, sin square theta upon cos theta into sin theta minus cos theta plus here cos theta into cos theta, that is cos square theta upon sin theta into cos theta minus sin theta. Here let us take LCM, cos theta into sin theta. Here it becomes negative. Observe. Okay. This one negative. Let us change this as negative because we want this as sin theta minus cos theta. So this is equal to sin square theta, this one, upon cos theta into sin theta minus cos theta plus this one cos square theta upon sin theta into sin theta minus cos theta. But now we have to change this sign as negative. So now we have LHS like this. What shall we do now? Sin theta, here LCM, sin theta into cos theta, this one and this one we have to multiply into sin theta minus cos theta. This one is common, no? So in the numerator sin cube theta, because LCM, here in the numerator cos square theta into cos theta, that is minus cos cube theta, that is equal to, here we can use a cube minus b cube formula. Denominator will be the same, sin theta minus cos theta into sin square theta plus cos square theta plus sin theta into cos theta. Here observe, sin theta minus cos theta in the numerator and in the denominator sin theta minus cos theta can get cancelled. So now we have sin square theta plus cos square theta is equal to 1 plus sin theta into cos theta. In the denominator sin theta into cos theta. So now we can separate it. How? 1 by sin theta cos theta plus sin theta into cos theta in the numerator upon sin theta into cos theta in the denominator. So this is equal to 1 by sin theta is equal to how much? Cosecant theta into 1 by cos theta is equal to secant theta plus this and this get cancels. 1, that is equal to 1 plus secant theta into cosecant theta plus 1. that is equal to RHS, hence proved. Now let us solve the 31st question, which is taken from the chapter Arithmetic Progression. There are two questions. You can solve any one of this. Now let us solve 31st A. Find AP whose third term is 16 and its seventh term exceeds the fifth term by 12. Also find the sum of first 29 terms of the AP. Now it has been given that A3 is equal to 16. It implies that A plus 2D is equal to 16. Let this be equation number 1. Why I have written A3 is equal to A plus 2D? Because the formula for the nth term of the AP is AN is equal to A plus N minus 1 into D. A7 is A5 plus 12. It implies that A plus 6D is equal to A plus 4D plus 12. 6D minus 4D. Rearrange. Here A and A get cancels. 4D transpose to this side is equal to 12. So 2D is equal to 12. D is equal to 6. Putting D is equal to 6 in equation number 1. A plus 2 into 6 is equal to 16. It implies that A is equal to 16. A plus 12 is equal to 16. A is equal to 4. 16 minus 12. Therefore, AP will be A is 4, D is 6. So, the sequence will be, arithmetic progression will be 4, 10, 16, 22, 28 and so on. Sum of n terms of the AP is Sn is equal to n by 2 into 2a plus n minus 1 into d. Now we are finding sum of first 20 terms. Here a is equal to 4, d is equal to 6, n is equal to 29. First 29 terms. Substituting the values in the formula, Sn is equal to this formula. So S29 is equal to 29 by 2 into 4 plus 29 minus 1 into 6. So S29 is equal to 29 by 2 into 4, here 29 minus 1 is 28 into 6. So it is equal to 2 into 4, 6, 8, 28 into 6 is 168. 29 by 2, 8 plus 168 is 176. 2 ones are 2, 8s are 2, 8s are. So S29 is equal to 29 into 88, that is equal to 2552. 2552. So the sum of first 29 terms of the AP is 2552. Now let us solve the next one, B, option B. Okay. Find the sum of first 20 terms of an AP whose nth term is given by An is equal to 5 plus 2n. Can 52 be a term of this AP? What has been given? An is equal to 5 plus 2n. So A1 is equal to 5 plus 2 into 1. So first term is 7. Now we have to find the second term A2, that is equal to 5 plus 4, that is 9. Now we can find D. A2 minus A1, that is equal to 9 minus 7, that is 2. Now let us substitute the values of A, D and N in the formula. Sn is equal to n by 2 into 2a plus n minus 1 into d. Let us substitute the values. So we get 20 by 2 is 10, 2 into 7 is 14, 20 minus 1 is 19 into 2. That is equal to 19 into 2, 32. 14 plus 38 is 52. So S20 is equal to 520. So sum of the first 20 terms of the AP is 520. So in this AP, A is equal to 7, D is equal to 2. Let 52 be the nth term of the AP. We have to check if 52 is a term of the AP. Formula for the nth term of an AP is n is equal to a plus n minus 1 into d. Now 52 is equal to 7 plus n minus 1 into 2. Now let us transpose 7 to this place. 52 minus 7 is equal to n minus 1 into 2. So 45 is equal to n minus 1 into 2. So n minus 1 is equal to 45 by 2. 45 by 2 is not an integer. So it is clear that n minus 1 is not an integer. So n is also not an integer. So 52 is not a term of the AP.